Okay, let's look at the homework 5.4, 5.5, problem number 13. Right? So we have this definite integral which represents the area of a certain region. Right? So let's look at that. Right? So this is going to be the area of the region between two curves, and you can see that the top curve comes first. So we know that this guy right here is going to be our top curve, right? Minus the bottom curve. So this parabola right here is the bottom one, right? So let's sketch these two guys. Alright, so the top one is fairly easy to do because it's going to be a straight line. Alright, so it's just x minus 5, so I'm going to go here. Alright, so we know that the y-intercept is negative 5, so we're going to just put 0 and the negative 5. Right? Then you can pick any random point on that line. So I'll try, x equals 1. And if x equals 1, 1 minus 5, so it's negative 4. So we can just put that in. So plug in 1. And y value is negative 4. Right? Then you have that. Right? So that's the first line. Right? The bottom one is the parabola, right? So when you do a parabola, what we need to do is we need to find the vertex, right? So let's find the vertex first. All right, so you have this equation, so I'm going to call it f of x, right? So that I can call it something, right? So you have x squared plus 4x minus 5, right? I remember the vertex formula, right? Vertex, right? If you watched the previous video, formula was negative b over 2a. Then corresponding y value would be just f, and then plugging negative b over 2a, right? Where you have quadratic function, so f of x is equal to ax squared plus bx plus c, right? So in this case, I'm going to just identify a value, b value, and the c value. So here, a value would be, right, so it's a number in front of x, which is x squared, so it's going to be 1, right? B is the coefficient of x, which is 4, right? And c, we don't really need c, but I'll do it anyway. So c is just a constant term, all right? C is equal to negative 5. All right, so if you want to find a negative b over 2a, right, that would be negative, b is 4, and 2 times a is 1, right? So you can cancel 4 and 2, so you have 2, so that would be negative 2, right? Then we can just plug in negative 2 into that original function f. So you see that, let's see, it's a negative 2 squared plus 4 times negative 2 minus 5, right? So this is going to be equal to negative 2 squared is positive 4. 4 times negative 2 is negative 8. And you have a negative 5, right? All right, so that's going to be, let's see, negative 4, negative 9, so negative 9, right? So therefore, the vertex is going to be -2, comma, -9, right? So this is the vertex, and if we'd like to have another point, so easy point to do is y-intercept. So another point would be so y-intercept. Right, y-intercept means that x is always 0 because it's on the y-axis. But if you plug in 0 in here, and obviously the value f of 0 is -5. So those are the 2 points that we can use. Right, so let's go back. All right, vertex was -2, comma, -9. Right, then y-intercept is 0, comma, -5. Right, so we have that, and what we need to do is to shade the region between those two curves. So I'm gonna just click on there. All right, that's that. All right, so the next step is to actually, is that the only step we need to do? Oh, looks like that's it. All right, so I'm gonna just go down and submit for testing. All right, it came back, and let's see, it looks like we got this one correctly. All right, that's it. I hope that this was clear.